Now, you are aware of the fact that several transition metal elements are said to have magnetic moment values. There are compounds which are said to be paramagnetic in character and also diamagnetic in character. A simple point about this is a paramagnetic compound will have certain number of unpaired electrons. The electrons present in that ion, for example, should be in the unpaired state. A diamagnetic compound will contain these electrons in the paired state. So if all the electrons in that ion are paired, it is diamagnetic in character. If even a single unpaired electron is present, then the compound is said to be paramagnetic in character. You are quite familiar with this expression mu s is equal to root of n into n plus 2. The mu s is spin only magnetic moment values. Spin only magnetic moment values. It is given by the expression root of n into n plus 2, where small n represents the number of unpaired electron. The number of unpaired electron. There is also another expression which will give the same result. Mu s, spin only magnetic moment, is equal to root of 4 into capital S into S plus 1, where capital S is known as the total spin. Total spin. For example, from this root of 4s into S plus 1, you can get n into root of n into n plus 2. This you can get. For each electron, the spin is said to be half. That is, capital S is equal to n into small s. Capital S is the total spin. Small s is the spin of one electron. Small n is the number of unpaired electron. For example, let us consider the first expression, root of n into n plus 2. If there is one unpaired electron, n equal to 1. So 1 into 1 plus 2, that is 1 into 3, root 3. If a compound contains one unpaired electron, then the paramagnetic moment, spin only magnetic moment, will correspond to root 3. All right. Let us apply this to this expression. There is only one electron. So capital S is equal to 1 into n, one unpaired electron, 1 into half. So this will become 4 into half, half plus 1. That is 2 root of, this is 3 by 2, so 2 by 2 root 3. So we can calculate the spin only magnetic moment for paramagnetic substances either using the expression mu s is equal to root of n into n plus 2, or mu s is equal to root of 4 into capital S into capital S plus 1. Now problems based on this will be asked. Of course, using simple calculation. Suppose you are given the spin only magnetic moment value, say, which is equal to some 1.7. I give you a problem like this. A compound for which the spin only magnetic moment is equal to 1.73. These magnetic moment values are expressed in Bohr magnetons. So a particular compound has the spin only magnetic moment value of 1.73 Bohr magneton. find out the number of unpaired electron. Now use this equation. Mu s is 1.73 and you can find a value for small n, number of unpaired electron, which you can notice will correspond to 1. Small n equal to 1, which will work out to root 3. So problems may be asked. A particular ion is given and you will be asked to calculate the spin only magnetic moment. Now in this connection I want to mention this point, namely in the transition series of elements we have first transition series, second transition series or third transition series. At least for 3D transition series, first transition series, you should remember the ground state electronic configuration of the elements. Then only you can find out the number of unpaired electrons from which the spin only magnetic moment you can calculate. So in both ways problems will be asked. If mu s is given, find small n, or if small n is given, you can calculate the spin only magnetic moment. For diamagnetic substances, already I have told you, diamagnetism means all the electrons are paired. There is not even a single unpaired electron. That means for a diamagnetic compound, usually we assume n equal to 0. So this spin only magnetic moment value, these expressions are applicable to paramagnetic compounds.